Hey guys, today I'm gonna explain about vectors and scalars. Let's hope help you to clear doubts. This is the fundamental of physics. It has huge applications in momentum and velocity and force. So it also has applications in momentum, which are quite important. Basis of physics, if you like to call it that way. And of course, it's quite important to know about them because it has a huge application. Basically, momentum is just an extension of the vectors and scalars chapter. It's of course it's by me. Yeah, yeah. First of all, I'm gonna clear up all the definitions. This is what I call the textbook definition. The textbook definitions, I've just copied them word to word to the textbook. Like you will have to write this in the examination. You understand what I mean? This is what I call an exam definition. You're gonna get full marks if you write this definition. Yeah. So what's velocity? Velocity is something that has, oh no, sorry, not velocity, vector. What is a vector? Vector is something that has oh well, magnitude as well as direction. Then what's a scalar? A scalar is preferably a physical quantity. Oh man, I just cut off the preferably, sorry. A scalar is a physical quantity which has its magnitude only. You understand? Magnitude only. So this has been covered lots of times in mathematics. Vectors, scalars, vector scalars. Like most of them, the vectors are the one teachers speak about all the time. Vectors, vectors, vectors. There's a chapter on them in pure maths as well as IGCSE or O levels. For scalar, no one keeps a chapter for them poor guys. But however, both of them are equally important. How to differentiate? What is the difference between vectors and scalars? Now you'd say, you just told me. Vectors have magnitude and direction, scalars have just direction, also just magnitude. So what is so I know the difference. You're gonna say that sentence, wouldn't you? But it's not enough if you know the difference. You must know how to differentiate. Differentiate, by differentiate I mean that you must know how to whether something is a scalar or a vector. There are only 6 vectors, only 6 of them, as you can see. So it's better to memorize the 6 of them. Yeah, I've just given an example for each of them under the conditions that you will need them. I've given the most popular examples, most likely to come out in the exams. Yeah, where are they? Where did they go? Yeah, the first one is meters. Displacement obviously is displacement. Displacement is displacement, yeah, meters per second. Velocity. Where's the third one? Acceleration. So all three of them have cousins, which I'll speak about later. The fourth unit is Newton, which is force. Okay, displacement, velocity, and acceleration have cousins called distance, speed, and acceleration as well. Okay, then what's the difference between displacement and distance? Displacement is a vector, distance is a scalar. Velocity is a vector, speed is a scalar. But acceleration is the same in both conditions, so there's no scalar cousin for acceleration basically, so you just have a vector only, acceleration. The three, displacement, velocity, and acceleration, only have the names as I have provided. They do not have any other vector names, whereas scalars, they have a lot of names, like I can say distance, length, breadth, width, lot of them. Like any length I can call distance, but I cannot call it displacement. The detailed difference between displacement and distance, velocity and speed, would be covered in the next video or the video after that, along with something very special, as I've mentioned in the last part. Another one is Newton meter torque, as it's come up on the screen. Another one is kg meters per second or Newton second. You may be thinking, for everybody I gave just one unit. For this I gave 2 units. Why? Because both units are equally used. Like they may ask for both units in the condition that you're writing an exam. They may not have mentioned on kg meter per second for years and just carry on with Newton second. They may suddenly pop up with kg meters per second. Do not worry. Please just think that they are the same units, and also yeah, please just think that they're the same unit. It's one and the same, okay? And they may ask for both, or they may ask you to prove that the other second is kg meters per second, okay? Note that it's not Newton per second, it is Newton multiplied by second, okay? When I first learned about it, I mistake it to be Newton per second. Okay, what's the next screen not appearing? No, my computer's a bit slow or whatever. Why is momentum a vector? I think I have a bit to explain on this topic. Momentum is vector because, can anybody recall the formula of momentum? I'm gonna give you some time. This is better rather than giving you the answer directly. Too much of spoon feeding is not good. The answer has popped up on the screen because it's related to velocity, also vector. Detailed explanations given in the next part when it is compared with kinetic energy. Okay, there's another reason. Can any of you think of it? I'm gonna give you a bit of time to think of it. Yeah, it is the simplest derived from the definition of a vector in the very first place. It has magnitude and direction. That's all. Basically, I'm saying that whenever momentum comes, it has a magnitude and the direction comes free. So it has to be vector, right? Rather than, I never mentioned the velocity in the second definition. I like the second definition, too less to write actually. So good for an exam, saves time. If momentum is a vector, just because of its relationship with velocity, why is kinetic energy not a vector? Can any of you predict the formula or say out loud the formula of kinetic energy and momentum? Anybody? I'm gonna give you some time. Okay, momentum is mass into velocity, as mentioned above. When the velocity is multiplied, the momentum will be in the same direction as the velocity. Mass has a magnitude, velocity has a magnitude and direction. So I've got a magnitude multiplied by a magnitude and a direction. So magnitude multiplied by magnitude gives another new magnitude. So I have a magnitude and a direction, which basically gives you a vector. Done. So in the conditions that they ask you, why is momentum a vector, what are you gonna write? Okay, here pops the second part. Kinetic energy is half mv square. When the velocity is squared, only its magnitude can be squared, for not its direction. This is quite important. Like they give you velocity squared. We invented a new unit, velocity squared. Is this a vector or a scalar? People are prone to writing vector. A lot of people lost their marks in that question. So just to make sure that you do not do any such silly mistake, only its magnitude can be squared. not direction. Unless you invent some kind of stuff to square direction, obviously. I'm gonna give you direction, for example, north. Square it and write it down in the comments below. So kinetic energy is a scalar. How do you add or subtract vectors? Okay, first of all, what can you do with vectors? You can add, subtract, multiply, or divide them. When you add or subtract, you got to keep the units, the direction, and you need to do the respective operator. You need to apply the respective operator to the magnitudes. However, if you multiply or divide, you do not need to keep the direction. Let me repeat, you do not need to keep the direction, because the directions, how do you divide a direction with a direction? For example, divide north, for example, north divided by south. Do it and write it down in the comments below. Yeah. So the detailed part is covered in the next video. Bye. Please don't forget to share, comment, or subscribe. Subscribe for the next video. Of course, you've got to subscribe for that. And of course, share with your friends so that they also know, they also score something in the exams. Of course, comment. I've given a lot of few options for you to comment. What if you have any questions? So what if you have questions regarding this video? Comment in the section below and then I will reply ASAP. Okay? So I'll reply ASAP. I reply